burn something though. So that's always fun too. So potassium chlorate, it's made from potassium, which is a metal. It's also made from chlorine and oxygen. Sorry, I gotta turn this over here where I can see it. But what's interesting is I want you to notice that this doesn't, when I add this in here, this potassium chlorate, it doesn't look like a metal. It also doesn't look, chlorine in its natural state is a green gas. So it doesn't look like a green gas, a metal, or oxygen. That's the three things it's made out of. Okay? Now, it doesn't look like that because the atoms have all recombined. Alright? And when they recombine to form this substance, potassium chlorate, it takes on, oof, that's terrible, a whole new look, which is this white powder here, potassium chlorate. Alright? Now, first thing we need to do is we need to heat this to the point which it's going to melt. So let's do that. Alright, so this is just a little, it's called an alcohol lamp. It's just used as a heat source. So we're going to set this back under here. Right there. And this is going to take a couple minutes to heat up and melt. I put a pretty good amount in there. But then here in a little bit, we're going to be adding some sugar in the form of a gummy bear. Alright?
Oh, yeah.
That's what we're going to use. Now, gummy bears, the sugar, okay, the sugar that you eat has carbon, hydrogen, and oxygen all packed inside of it. Okay? Carbon is, we talked about, where can you find carbon possibly at your house? You may cook on this. It's outside. The grill, yeah. You have a charcoal grill. Okay, charcoal is carbon. Okay, so that charcoal that's in your grill, that black gross stuff that you have to get out every once in a while, that's in sugar. Okay, but since it's combined with hydrogen and oxygen, it makes a really tasty substance we call sugar, and you can eat it, and it tastes good. All right. Now, now think about that though. We just said in sugar we have carbon. What color is, or carbon comes, we have charcoal. Sorry, let's start over. Sugar does have carbon, okay? We said carbon, you can find it in the charcoal in your grill. What color is charcoal?
Black.
Black, okay, so do we see a black color in the bottom of this test tube? Yeah, what do you think that black stuff is?
Charcoal.
Okay, charcoal, which is also what? We said carbon. Yeah, it's the carbon that's packed into the sugar. So this little chemical reaction that we're going to do, it's going to release all the carbon out of the sugar, and it's going to end up right here on the bottom of our test tube. All right? There will be some fire because there's also oxygen in sugar, and oxygen is able to do what? If you put a match to it, it can... No, not explode. I mean, it could, it burns, yeah. Okay, it burns. So, what's going to happen is, the reaction we're going to make in here, all right, it's going to separate the carbon, the hydrogen, and the oxygen. When it releases all that energy, it releases heat. That heat will cause, what do you think will happen to the oxygen? The oxygen, if you add heat to it, it will burn. It's going to burn and catch on fire. You're going to see a lot of really cool light going on. Okay, I promise you're safe if you're here. It's not going to blow up. Okay. So you're getting really far away. Okay. All right. So it's starting to get a little bit. It's getting hot here. Turning to liquid, so it'll take a little bit. So let it sit for a little bit longer. So this is, again, this is the afterwards. So here's a clean test tube. This is what it's going to end up turning into. You can see the comparison right there between the two of them. There's a big difference there. All right, so I'm going to set this guy back over here. But so there's a lot of energy in here. We watched in that video at the elements. I talked about when the elements combine or they separate, okay, that they're releasing energy, okay? And what did we say happens for elements to combine? What has happened to their valence electrons? There were three things that can happen. They can either, one starts with an S, two starts with an S.
Sugar.
Oh, yeah, good, yeah. They can share electrons, okay? Or they can, one starts with the L. Lose electrons, one starts with a G. Or gain, yeah. So that's what we're seeing happen, okay? Is when we throw this gummy bear down here in just a minute, we're going to see electrons being gained and shared and lost all across. And when that's happening, then that's that energy that's being exchanged there, okay? And it's going to be very dramatic. We're getting there. We've got some liquid at the bottom. Let me kind of shuffle this around in here a little bit.
Was that the gummy bear?
No, I haven't put the gummy bear in yet.
So we can get a boom or what?
You'll see. So this is kind of like the difference between if you try to jump in a pool full of really hard jello versus jumping in a pool of water. We want the gummy bear to be like jumping into water where all the liquid will surround it versus jumping into the powder where nothing will really happen. Yeah, if only.
Actually, you can make that in the winter, right?
Alright, we're getting there. In the winter. Yeah, that's a good hypothesis. Don't much of gelatin in your pool in the wintertime. Good luck cleaning it out, though.
I know people.
There's bugs.
Just eat it. Just eat it all out.
That'll take forever, won't it?
No, it take a while.
So you'd be getting salt water.
Speed it up.
We never put chlorine.
Firepower.
Did that ever
Flame on.
in your hand before? Fire back.
No, I'm trying to speed up the melting here because I put a lot in here.
Because they know I got fun.
Well, yeah, it's more.
Take all the time you need.
So I know this is really awesome footage right now. Like, ooh, look, fire's melting it. So exciting.
Fire back.
You can pause it.
It's out.
Hey, just
It's out of gas?
Good. I still got some.
fire. Just like put the trigger and use it from the other fire too.
All right, I think we're almost there though. It's mostly melted.
Hey.
And then the fire.
Somebody put peanut butter in the.
Hopefully it works well. I've not repeated this
Later.
in a test tube that we've already used once. So that's going to be new. Let me poke the rest of this down in here for us to make sure we got it all. Yep. Sorry, that's part of the reaction. That means there's some sugar on there. All right. Well, yeah, because when you see what happens, you're going to see why I don't hold my hand there. All right, let's turn this on. All right, now's where you really want to record if you haven't already been recording.
Mr. Bowman.
Just drop this in here. Move all the stuff out of the way. And
Whoa. Oh my god. That is so cool. That is so weird.
that's really bright.
If that was you,
what would you do?
I was slightly hoping it might get an explosion out of it. I had seen this done on videos where like the test tube explodes. Alright, we're going to let that sit there and the gas continue to get vented out, so we don't have that in here. So, that's our cool demonstrations. We've just taken all the energy out of the
Drop another
sugar.
one in there.
Do what?
That one's different than the...
It does, well, it'll keep changing. If you watch it, it's going to get darker at the bottom. The more it sits there, the more it'll continue to get darker. Like I can even see on this side, it's getting darker.
You should blow up that fire, you know?
I'm going to do this though. There we go. Alright, so we'll let that sit there. So there.
I know.
Now, that's